Okay. So I just decided that it might be a good idea to record this since there's a lot of people absent. So they sort of missed the example, but let's do this one out so we'll make sure everybody's on the right track. If this is your point, -2, -1, you are on the coordinate plane back to this direction 2 and down 1. So back 2, down 1. Here's your right angle, here's your theta. So the length of this side is 2, the length of this side is 1. We're going to do Pythagorean theorem to get the radius. When you do that, you get that the radius is the square root of 5. So there's your triangle. All right, so when you do sine of theta, you're going to do opposite over hypotenuse. That's -1 over root 5. Remember, you need to rationalize the denominator. When you rationalize the denominator, you're just multiplying the top and bottom by whatever the radical is in the denominator. So multiply top and bottom by radical 5, and you get -√5 over 5. And that should be your sine. Do you have a question? Nope, I rationalize the denominator. So when there's a radical on the bottom of a fraction, you can't have a radical on the bottom of a fraction. So you have to multiply the top and bottom by that radical. So I'm multiplying by radical 5 over radical 5, which just has a value of 1. So we're not really changing the value. We're multiplying this thing by 1 whole, but we're putting it in a different form so that the denominator is a whole number instead of a radical. So across the top, you get negative radical 5. On the bottom, when you do root 5 times root 5, it just becomes plain old 5. Okay, so cosine is adjacent over hypotenuse. You're going to do -2 over radical 5. And when you rationalize the denominator, that becomes -2 root 5 over 5. And then tangent is opposite over adjacent, which is -1 over -2, which is just a positive 1/2. That makes sense? And then remember, cosecant just is the reciprocal of sine. So instead of using my already rationalized one, you guys, we were talking about, you know, turning it back, right, the reciprocal. Since the problem with my sine was that I had a radical in the denominator, that doesn't become a problem when we make it the reciprocal, right? So I could go back to my original negative, right here, -1 over radical 5, do the reciprocal, and I just get negative radical 5 over 1. You see what I'm saying? Instead of doing the reciprocal of this one, then I'm going to have to rationalize the denominator again, right? You know what I'm saying? So go back to the original instead, and then you don't have to do that process again. It should come out the same both ways. But okay, so secant is 1 over cosine, or the reciprocal of cosine. So again, it's going to be negative radical 5 over 2 if we use this one to reciprocal. And then cotangent is just the reciprocal of 1/2, which is 2. Okay, so notice in the box up at the top of the notes on that page, you know, this box, like I said, is not really talking about the unit circle. It's talking about any circle, right? Any xy axis. And so these problems that we just did are dealing with not the unit circle, right? The radius was not 1 in the examples we just did, but it's still, you can do that with any angle, right? If you know a point that's on that angle. So over here, I just kind of put the unit circles so that you are thinking about it as relating the same way. If it's the unit circle, we have the x and the y, or the -x, -y, whatever quadrant it's in. But the radius on the unit circle is always 1, which kind of if you think of cirkix or ticks or whatever, so I think I wrote that wrong. How do you say it? Oh, kicks or ticks. Yeah, I don't. That one does not work for me. But anyway, if you think about the fact that the R is always 1, right? Then the sign just becomes y. Because y over 1 is just y, right? And the cosine just becomes x. Over 1 means nothing, right? So sine is y and cosine is x. And then the tangent is just sine over cosine. So let's look at the next page. I move this. And there's the unit circle for you. I know it's small, but you just created it largely, so you have that one as well. But there's the unit circle for you to refer to. All right. The quadrantal angles. Quadrantal angles are just the angles that are at the that are on the axes. So every 90 degrees type of thing. All right. So if we're finding, and now we're talking about the unit circle. Because in general, no matter what angle we use, the ratios are going to be the same. Right? So no matter what radius we have, the ratios are still going to simplify to these ratios. That's why we just use the unit circle, because then it already gives us our ratios in simplified form. Okay, so doing the quadrantal angles, if you have the unit circle in your brain, you're just thinking about the x and y of those 90-degree spots, right? 90, 180, 270, and 360. Now, I want you to kind of notice this. You might want to highlight that, because you might not have thought of this before, but it's the way you should think about it. Because like we said, right, this point, for example, is what you go over x and up y. Well, if you think of this as theta, and this triangle that we created before, right, if you're going over x and up y, this distance is your x, this distance is your y. If your radius is 1, then when you do sine of this angle, it's opposite over hypotenuse. It's just y over 1. And the cosine is just x over 1. So when you think of these ordered pairs, yes, you could think of them as xy, but you can also think of them as cosine, sine. You go over cosine, up sine. This might be new, a new thought. Is that not a new thought? Have you thought of that before, as over cosine, up sine? You guys awake? Did I lose you all? I'm letting that sink in a little bit, because I'm going to use that. Over cosine, up sine. Instead of over x, up y, this is why I don't need cirkix or ticks, because I just think of it as over cosine, up sine. And then, all right, so over cosine, up sine. Tangent is just sine over cosine. So I'm going to write that here. Tangent equals sine over cosine. That's the way it works in my brain, anyway. And I didn't type this, so clearly somebody else thinks of it the same way. Over cosine, up sine. Now, think about this. When you think of it as xy, that's alphabetical. X, Y, Z, right? X, Y is alphabetical. Cosine, sine is alphabetical, right? So C comes first, and then the sine. So cosine, sine. Cosine comes first, alphabetically. Yes. the y. Sine is y.
Oh, right. So that you could do let's say like that was at 5 or whatever, and it would just be 1 over.
Sine is 1/2 of this one, 30 degrees. Nope. Yep. Because if I ask you to find the sine of, let's say, 3 pi over 4, okay, so think, pi over 6, the sine is 1/2. Yep. So otherwise you might always be thinking about, I don't know, opposite over hypotenuse or kicks or ticks or whatever, and you're thinking about, to me this is just an easier way to think about it, and maybe that's how you always thought about it, I don't know. Okay, so let's do these. Okay, so we're talking about if our theta is 0. Theta is 0. So where are we on this unit circle? We're right here. Right? 0 degrees. Right here. Okay, so that's where we're talking about. 0 degrees. And we're going to do all the trig functions. Well, what's the ordered pair at 0 degrees? 1, 0. So if we think of this as cosine, comma, sine, right, alphabetical, cosine, sine, then it becomes easy. What's the sine of theta? 0. What's the cosine? What's tangent? Sine over cosine. Cosecant, you have to do the reciprocal of sine. So 1 over 0 you can't have 0 on the denominator of a fraction, right? That blew up everything every time, right? Asymptotes, we got all sorts of issues when we got a 0 in the denominator of a fraction. So cosecant does not exist. Secant is 1 over cosine. Right? 1 over 1 is just 1. You have to be careful of cotangent. Well, tangent and cotangent you have to be careful of. Because remember that tangent was 0 over 1. Right? So the cotangent is 1 over 0, which doesn't exist. That makes sense? All right. Pi over 2, which is 90 degrees. What are the x and y coordinates of that? Over 0, up 1. Fill that box. Okay, is that what you got? All right. So, did you keep going? Not yet. So 180 degrees, what's the xy of that? Negative 1, 0. Then 270. All right, so you should be able to fill in those 6 trig functions. All right, so check, make sure you have them in the right spots. Yep. Oh, okay. So, so some of these you have to be careful when you reciprocal them. For example, this one, you might guess that, since tangent is undefined, you might think, well, when I reciprocal that, it'll be undefined again. But remember, that just meant that the denominator was 0. When you make the reciprocal, the numerator becomes 0. And it's okay to have the numerator as 0. So cotangent turns into 0, not an undefined. And here, this is the one you were asking about? Nope, because it's just -1/1. Or 1 over -1. So one of them is negative, one of them is positive. It makes the whole thing negative. Okay, so if you try finding specific values, think about the unit circle with the radius of 1. If you have, and these are all still quadrantal angles, right? But they're talking about them a little bit differently. This is -180 degrees. It's still going to be the same as 180 degrees, right? And if you're talking about the sine, remember that's the y. So what's that going to be? 0. Right? Now, tangent, we said, is sine over cosine. So if you're talking about 3 pi over 2, 3 pi over 2 is at this spot on the unit circle, right? 3 pi over 2. So that's over 0 down 1. Cosine, sine, you're talking about sine over cosine, this becomes undefined, right? Because the cosine is 0. Secant of 4 pi. Well, where's 4 pi on the unit circle? Same as 2 pi, right? Because you just go around twice. So 4 pi is going to end up here as well, right there. So that's 1, 0. And secant is 1 over cosine. Cosine is 1, so it's just 1 over 1, which is 1. And then cosecant of pi over 2. Again, pi over 2 is at the 90 degrees. So that's over 0 up 1. Cosecant is 1 over sine. The sine in this case is 1. So 1 over 1 is just 1. All right. So what if we have angles that are not the quadrantal angles? I mean, that's all well and good. You've got your zeros and your ones and your negative ones, but we know that on the unit circle, they don't all come at those nice spots, right? We have to deal with all of the other angles as well on the unit circle. Again, we can derive these from these special right triangles. This is an equilateral, this is an equilateral triangle right here. This is a square right here. If you cut a square in half, you get a 45, 45, 90 triangle. If you cut an equilateral triangle in half, you get a 30, 60, 90 triangle. I'm actually looking at the time and realizing that I need to move on a little bit. So this is really the derivation, which we did last week, of how you get those spots on the unit circle that are here, right? Root 2 over 2, all of those. This is how we derive it. I'm going to come back to that next class. Because you're still going to be able to refer to your unit circle. We have it all filled out, right? So 6 trig functions for angles that are not quadrantal angles. If this is 45 degrees, what's the xy coordinate of 45 degrees? And you can look at your unit circle. Root 2 over 2, root 2 over 2. So if we do the 6, we got sine, cosine, tangent, and then we've got, if you want to do sine with cosecant, I guess I'll just do it underneath though. Cosine, sorry, I did that wrong. Cosecant, that's what happens when you try to hurry. Cosecant, and then secant, and then cotangent. All right, so in all these cases, we're talking about theta being pi over 4 or 45 degrees. Okay, again, think about this ordered pair as cosine, sine. So what's the sine? Root 2 over 2. What's the cosine? Root 2 over 2. Remember, tangent equals sine over cosine. If sine and cosine are the same, we put them over each other. What does that equal? 1. Cosecant is the reciprocal of sine, so that's 2 over root 2. Again, we need to rationalize the denominator. So we multiply top and bottom by root 2. You get 2 root 2 over 2, which is just root 2. That make sense? Reciprocal of secant is going to be the same thing because sine's the same as cosine in this problem. Cotangent, we do the reciprocal of tangent, and that's again just 1. Make sense? Okay. Pi over 6. What's the xy value of pi over 6? Well, if you look at your unit circle, pi over 6 is the 30-degree mark, right? What's the x value? And then 1/2, right? So in my brain, I think, okay, this is the 30-degree mark, so it's the longer one first. Square root of 3 over 2 is bigger, and then the shorter one is 1/2. Okay, so again, sine, cosine, tangent. Sine is just 1/2. Cosine is root 3 over 2. Tangent, which takes a little bit of work to get tangent, right? We need sine over cosine, which is 1/2 over root 3 over 2. I'm writing out the long way, but you should think about that. Remember, dividing by a fraction is the same thing as multiplying by the reciprocal. See how important fractions are, right? So you're really doing 1/2 times 2 over root 3. When the 2's cancel, you get 1 over root 3, and then you have to rationalize the denominator. So you get root 3 over 3. All right. So let's figure out homework here. So homework is finishing this one, and then 1 through 6 on the very back where it says practice.